Welcome to another GCBASIC demonstration. This is a GCBASIC demonstration for the PIC18xxQ20 chip family. So first things first, I need you to subscribe to the channel and also like this video and just let it run to the end, okay? I'd be really grateful and that will really help the channel. So let's get straight into the video. This is number 3 in the sequence, and what we're going to do is we're going to set the LEDs that we had running yesterday, and we're going to actually, we're going to put some values of the ADC on those LEDs. Now later on, we're going to put the ADC signals to terminals and other devices, but we just need to get the ball rolling with some LEDs. So what am I using? I've got some hardware. I have a prototype board. I'm powering it from 5 volts. I have a programmer. I'm using a PIC Plus with a PIC2. Go download that from www.pickitplus.co.uk. And I've got some LEDs and resistors involved. So I've got, as you can see on the screen, I've got an ADC. I've got a potentiometer on port A0, and I've got the same 4 LEDs as I had on the previous video. So what we're going to do is going to configure the ADC, we're going to run a conversion, we're going to read in the analog voltage controlled by the pot or the potentiometer on that board, and then we're going to display the results on the LED. So what does that look like? It looks like this. I have very clearly connected the ADC. In this particular chip, RA0 is on pin 19, and I've connected that through a resistor and into the 10K pot as shown in the diagram. So I've got, let me bring a pen up. I've connected RA0 through a potential, through a pot. There's a little capacitor as well, through to a 10K pot. And as I'm going to increase the value and decrease the value of the pot, we're going to get different values returned. It's extremely simple, but it is analog to digital conversion. So what's going to happen is GCBASIC is going to complete the initialization of the ADC for you. It does it automatically. We need to create a variable. First time we're going to create a variable, and we're going to put the results of the ADC value in there. And then we're going to read the ADC. It's quite simple. It's called read ADC. It's a function, and we pass it the name of the ADC we want to read. That's AN0 in this particular case. And we'll get a value back. And it's a value because it's a byte value between 0 and 255. And with the result of that, we're going to set the LEDs. And then do it all again. Let's have a look at that in terms of a flowchart. So, top of this, we're going to read the ADC. I'll bring my pen up. Read the ADC. We're going to set it. It will initialize it. We're going to create a variable. We're going to read the ADC. And then, depending on what value it is, it's being returned, we're going to set some LEDs like this. Or we might set all 4, depending on what the value is. But whatever's going to happen, it's just going to return back and do it all again. So it's a loop. We're going to see quite clearly a loop in this program. So we are going to see a loop because there is a loop in here. So let's examine some sample code and review the results. Okay, let me just start up GCStudio. Now, what we're going to see is GCStudio is going to actually try to update. It always does that. It always checks to see if it updates, but I want to show you this, how you can get out from it if you need to. Just press the close key and you end up in a dialog like this. Let me just move the screen around so you can see it. I'm going to open a local folder, and the folder that we're going to be using is going to be my D drive. It will be in your local drive for you guys, but I'm just going to take the master board, and it's Great Cal Basic. It's a Q20 demonstrations. Where are they listed here? There we go, 18FX6Q20, and I'm going to select that as a folder, and it will open the whole thing as a folder. So we're going to see where we left it yesterday. If I actually select the editor, I'll bring it onto the screen in front of us. There we go. And this is the folder that we had left open yesterday, and this is where we left the program. It was blinking, that was rotating the LEDs. Let's have a look on desk cam. Desk cam, we've got the LEDs, they're rotating as we left them in the previous video. I've got a chip, it's connected via 4 wires into the resistors, and the resistors are connected to these LEDs. And there's the chip. You can see it all. This is the programming cable. You can see it all. So in my program, we're going to look at that now, and we're just going to select program 50, and I'm going to close all the others, just have this one on the screen. And then I'm going to close the window on the right-hand side by pressing Control B. Excellent. That's where we left it yesterday. So, anything in green, we don't really want to review today because I'll talk you through it. So what are we going to do? We're going to set the chip. It's a 16xxQ20, option explicit. We'll look at that. Here is my LEDs. They're connected here, and I put an ADC in here. So I'm going to update my documentation. There we go. ADC is connected there. So what I've done, same as previous video, I've defined the LED port as lat-C, and I've created 4 constants called LED D7 to D4 on the particular ports, 7, 6, 5, and 4. Then I've set those ports as out. That is no different from yesterday. I've defined my potentiometer as RA0. That's the port it's connected to. You know, that for consistency, I ought to call that port A.0, just for consistency. And then there's a potentiometer, and I'm going to set that as an input. Now, in terms of digital and analog inputs, Great Car Basic used to take care of that. Now GCBASIC does the same. So let's create a variable to put our results in. Dim ADC value as a byte. Well, will create automatically for you in memory of a variable called ADC, and it's a byte value, so it can contain 0 to 255. Other types are word, longs, and integers, and other. They're all in the help file. But dim ADC is our particular one. Now we have a do loop, and this do loop here is a do loop to the bottom. Here it is do something, wait, and then do a loop. So every 100 milliseconds, it's going to do whatever it's going to do for us. This is the command to read the ADC. Read AD. If I press function key F1, it will bring up the help on read AD, and there's the help. And it says in here, it's a byte variable. Read AD with something called ANX, and the X is AN0 in our case because that's what was on the documentation. ANA0, AN0 is the same, and we'll leave that. So he's going to do the ADC read and put it in ADC val. Very simple. And then we're going to do something that's called a case select. We'll do it 2 ways in a minute. Case select, it says, right, select a case, and if that case of ADC val is 0 to 49, turn off the LEDs, like turn all 4 off. 50 to 99, turn on LED 4. 100 to 149, turn on 2 LEDs, D4 and D5. 150 to 200, you can read that. Else, set it to turn all 4 LEDs on. Very simple. So what I did there is I pressed that little arrow on the left there to minimize the code. But you can see there's clearly joins in here. You can see it's all sort of joined up and together in terms of what it's doing. Let's indent that. Now, I'm going to program, make sure the hexadecimal file compiles, function key F4, hex. Or you can press function key F4, or you can use the little icon at the top here. Does the same thing, and it says it's compiled successfully. This is used 8 bytes of RAM, but we only defined 1. That's because GCBASIC has created temporary variables for all the other things that are required to make this work. So you don't have to worry about that because the only one you're interested in is your ADC valve. The rest are done automatically by the system. Let's program it. Let's go out to desk cam and we'll see this work. Here's my little screwdriver. There's a potentiometer. Actually, I'll change the potentiometer cable. Here it is, it's cabled up. I'm just going to connect it to this pot here. And as I rotate this potentiometer, that's obviously the value of 0 to 50. We must be at 100 there, 200, etc. So if we look at our program, the values, anything above 200 will be all 4 LEDs on. You can review the code yourself. As I wind that back, it rotates back. Very simple. But we know that that must be a value of between 0 and 255. But do we actually know the value? We'll see that later on. But what we've done, we've created our first program using a variable. Variables are very important. We can do this all another way. So what I'm going to do is just show you another way to do this. I'm just going to comment all that out. There we go. Just commented the whole thing out. Just to prove it, it's done it. It's all gone green. And down here, I've got an if statement that does pretty well the same. The similar code, if statements, people may be more comfortable with. And it says here, if the value is less than 49, it should be 50. 49. If it's less than 50, turn them off. If it's greater than 49 and less than 100, I think that's what that should be. Turn on one LED. If it's between 99 and or less than 150, turn on 2 LEDs. I think that should be 149, maybe. Well, you let you play with that yourselves. In between, if the ADC value is between 149 and less than 200, then turn on 3. Else, if it's greater than 200, turn on 4. Okay, we can compile that. Press function key F5. That's the same as selecting it through the function key. Desk cam. That's where we left it. Turned it fully off. We get 1 LED, 2 LEDs, 3 LEDs, 4 LEDs. So what we've done is essentially reading the value from the potentiometer, which is the analog value. We've converted that into a digital value, and we're representing that on these LEDs. Rather simple, using GCBASIC. Let's go back to our slides. So that's all I wanted to cover is setting the LEDs to represent the value of an ADC. We've done it 2 ways. We've seen how to create a variable. And we've seen the consistent use of constants to run that through. Next time we're going to look at using the same LEDs. We're going to have them back in sequence, but we're going to use a delay from the result of the ADC. So we're going to use the ADC to speed up and slow down the LEDs. Until then, enjoy.